Hi guys, this is Saurav here and welcome to the first chemistry session for the JEE Sprint 2.0. Just like December's JEE Sprint sessions, this session is gonna be awesome because we are gonna cover as many topics as possible so that your sailing to JEE mains, which is gonna be held in the month of April, is as smooth as possible. JEE Sprint December was a grand success because of the nature of questions that we had taken and the kind of response that we had obtained. Like we had obtained a lot of responses from students who just by following JEE Sprint lectures were able to scale their scores as high as 95-96 percentile. So it is extremely important that you follow these lectures as religiously as possible. टाइम निकाल के इन सारे लेक्चर्स को देखिए क्योंकि इन सारे लेक्चर्स में हम उन टॉपिक्स को डिस्कस करेंगे जो कि आपके लिए बहुत ज़्यादा इम्पॉर्टेंट हैं. और सिंस केमिस्ट्री की बात आती है, सो वी हैव फिजिकल केमिस्ट्री, ऑर्गेनिक केमिस्ट्री, इनऑर्गेनिक केमिस्ट्री, 3 सेक्शंस. इस बार का फोकस थोड़ा इनऑर्गेनिक केमिस्ट्री पे ज़्यादा रहेगा एंड दैट इज द रीजन इनऑर्गेनिक केमिस्ट्री के सेशंस थोड़े ज़्यादा लिए जाएंगे. ये सेशंस जो रहेंगे इसके को अच्छे से समझने के लिए इट इज एसेंशियल दैट यू सिट विथ अ पेन एंड अ पेपर एंड प्लीज डू रिमेंबर दैट रिवीजन इज वेरी वेरी इंपॉर्टेंट. शॉर्टकट्स आर नॉट गोना गेट यू एनीवेयर. इट इज इंपॉर्टेंट दैट यू फॉलो अ वेल डिवाइस्ड पैटर्न. मेहनत कीजिए, उसका रिजल्ट आपको मिलेगा. डोंट वरी अबाउट वॉट एवर हैपेंड इन जनवरी. जिसका रिजल्ट आपके कंट्रोल में नहीं है, डोंट वरी अबाउट दैट. व्हाट इज इन योर कंट्रोल इज व्हाट यू कैन डू राइट नाउ. सो without wasting any more time, let's start with today's session. And the first session is on a very important topic which is known as chemical bonding. So chemical bonding से हर साल questions आते हैं, and to know what is the relative weightage for chemical bonding when it comes to inorganic chemistry, it comes under the topic of inorganic chemistry. So inorganic chemistry का पहला topic है chemical bonding. What is the weightage? The physical chemistry, organic chemistry, physical chemistry, inorganic chemistry has equal weightage. Equal weightage होने के कारण you can't ignore one and go with other two. So you need to have equal you should give equal importance to each of these three. और इसके लिए important है कि आप सारे topics at least 85 to 90% of the topics को अच्छे से करके जाएं. Okay? Inorganic chemistry के कुछ important topics हैं. I'll tell you later within the session that which topics are quite important in inorganic chemistry, and these are to be done very religiously. Inorganic chemistry के लिए the most important book is NCERT. Try to read NCERT line by line, solve the questions which are given at the end of the textbook. Also, it is important that आप exemplar problem series को solve कीजिए. उनमें जो questions आएंगे उनसे बहुत समय questions directly उठा के डाल दिए जाते हैं. Okay, so NCERT is the Bible for inorganic chemistry. Organic chemistry, physical chemistry के जब sessions आएंगे तब हम उनमें आपको बता देंगे कि what to follow, what not to follow, what to leave out, so that you should focus exactly on those questions which you should attack to get a score of more than 250. And like if you want to, you can scale it beyond 300 as well. So let's look at the division of marks for inorganic chemistry, or division of marks मैं नहीं बोलूँगा, मैं बोलूँगा कि questions. So if I look at the topics, you can see periodic salt analysis, coordination, chemical bonding, metallurgy, and what we have over here is group study. Group study means S block, P block, D block. इनको हम बोल देते हैं group study में एक we have identified that part as group study. So what we can see over here is that in 2018, in the offline as well as online examination, a total of 11 questions came from chemical bonding. That was the maximum, biggest chunk of all these sections. 4 questions, 3 questions, 5 questions, 5 questions. So inorganic chemistry में chemical bonding से हमेशा question आएंगे, and chemical bonding का एक thorough idea होने के कारण you can do really good in organic chemistry. Let's dig into the session, and this session will be conducted in a very systematic manner. हम लोग करेंगे क्या कि हम जनवरी में जो केमिकल बॉन्डिंग से क्वेश्चंस आए हैं पहले हम उनको पकड़ लेते हैं, देखते हैं कि कितने डिफिकल्ट लेवल के क्वेश्चंस हैं, एंड देन विल गो ऑन टू सम अदर क्रिटिकल कंसेप्ट क्वेश्चंस. सो द फर्स्ट क्वेश्चन फॉर द डे इज from JEE Mains 2019 January session, which was I think the morning session on 9th of January. So the question reads as, in which of the following cases the bond order has increased and the paramagnetic character has changed to diamagnetic? So bond order change हो रही है, also the paramagnetic character is changing into magnetic behavior is also changing. So bond order is increasing, magnetic behavior, paramagnetic is changing into diamagnetic. Now to solve this question we need to know molecular orbital theory, but let's say molecular orbital theory आपने पढ़ा है but you want to solve this question the minimum amount of time, so what you have to do is that you have to remove that there's a baseline, and the baseline will be taken as nitrogen. नाइट्रोजन मॉलिक्यूल में 14 इलेक्ट्रॉन्स हैं एंड 14 इलेक्ट्रॉन्स अकाउंट फॉर अ बॉन्ड ऑर्डर ऑफ 3 एंड डायमैग्नेटिक बिहेवियर. दैट्स द बेसलाइन. सो हमारा बेसलाइन ये बन जाता है N2 मॉलिक्यूल विच इज हैविंग 14 इलेक्ट्रॉन्स, डायमैग्नेटिक प्लस बॉन्ड ऑर्डर ऑफ 3. This is the baseline. Now, what you have to do is, what you have to remember is that if you add an electron or remove an electron, the bond order, when you remove an electron or increase an electron, the bond order will always decrease by 0.5 units. Okay. So, what does it mean? That if I change N2 to N2 plus, N2 plus में अगर चेंज हो रहा है तो यहाँ पे आपके पास हो गया 13 इलेक्ट्रॉन्स, नंबर ऑफ इलेक्ट्रॉन्स डिक्रीज किए, डायमैग्नेटिक से पैरामैग्नेटिक हो जाएगा, एंड बॉन्ड ऑर्डर विल बिकम 2.5. सो वेदर यू आर इंक्रीजिंग द नंबर ऑफ इलेक्ट्रॉन्स और डिक्रीजिंग द नंबर ऑफ इलेक्ट्रॉन्स, यू हैव टू ऑलवेज रिड्यूस द बॉन्ड ऑर्डर बाई 0.5. ठीक है. सो ये हो गया N2 का केस. ये वाला केस देखते हैं. NO, total electron count is 7 plus 8, that is 15. 15 electron count means 15 electron count means a bond order of 2.5. 14 से एक इलेक्ट्रॉन ज्यादा है, so हमने बॉन्ड ऑर्डर को 0.5 से रिड्यूस किया. It will become paramagnetic. If I take NO plus 14 electrons, bond order 3 will be diamagnetic. O2 changes to O2 2 minus. O2 जो है, O2 में 16 इलेक्ट्रॉन्स होते हैं, 2 इलेक्ट्रॉन ज्यादा 14 से. So this will be paramagnetic. O2 को आपको याद रखना होगा कि it is paramagnetic. Oxygen is paramagnetic. Bond order is 2. O2 2 minus is 18 electrons. Diamagnetic. Bond order is कितने हो गए? 1. ओके. सो 14 से 16 आते हुए 2 हो गया, और 2 इलेक्ट्रॉन आपने ऐड किया तो 0.5 से 0.5 टाइम्स 2 और आपने रिड्यूस कर दिया, तो दैट बिकम्स 1. एंड O2 to O2 plus, that is 15 electrons. 15 electrons will be para. Bond order is 2.5. So ये तो होगा नहीं. हमको क्या चाहिए? We want the bond order to increase and the paramagnetic behavior to change to diamagnetic. Bond order to increase and paramagnetic behavior to change to diamagnetic. This is what is happening over here. So the correct answer for this question is B. This question can be solved within a minute's time or 2 minutes time, and that and you'll always end up getting a right answer. So baseline is 9 N2. Let's move on to the next question. Next question is again from molecular orbital theory. ये भी January 9th के session में आया था. This came in the evening session or you can say the afternoon session. देखते हैं इस question को कैसे solve करना है. According to the molecular orbital theory, which of the following is true regarding Li2 plus and Li2 minus? So both are unstable. Li2 plus is stable and Li2 minus is unstable. Li2 plus is unstable and Li2 minus is stable, and Li2 plus is more stable than Li2 minus. Let's see what is the right answer. Both are unstable. How do we know that whether it is unstable or stable? हमेशा याद रखिए that if a bond order turns out to be 0, the entity will turn out to be unstable. Okay, so if a bond order is 0, entity will turn out to be unstable. Now lithium Li2 turns out to have a total number of electrons as hydrogen, helium, lithium. So total number of electrons is 6. MO configuration for this will be written as sigma 1s2, sigma star 1s2, sigma 2s2. So ये दोनों हो जाते हैं bonding molecular orbital, and this is the anti-bonding molecular orbital. Okay. Now, if I have to calculate the bond order for this entity, what I'll do is bond order is equal to half of number of electrons in bonding molecular orbital minus number of electrons in anti-bonding molecular orbital. So, number of electrons in bonding molecular orbital is 4 minus 2, that is 1. Okay, 4 minus 2, that is divided by 2, that turns out to be 1. Now, if you have Li2 plus or Li2 minus, the total number of electrons does not turn out to, the bond order will not turn out to be 0. Okay, let's see. Li2 plus total number of electrons कितने हो जाएंगे? 5 electrons होंगे. हम electron कहाँ से remove करेंगे? यहाँ से. So this will be sigma 1s2, sigma star 1s2, sigma 2s1. Okay, now the bond order for this would be 2 plus 1 3 minus 2 is 1. This will be 0.5. Let's try to calculate it for Li2 minus sigma 1 is 2. This accounts for how many electrons? Li2 6 plus 1 7 electrons. ठीक है, यहाँ पे 7 electrons हैं, and sigma 1 is 2, sigma star 1 is 2, sigma 2 is 2, and sigma star 2 is 1. Okay, sigma 1 is, sigma star 1 is, sigma 2 is, sigma star 2 is. Please do review this part क्योंकि this is how it will be written. So ये दोनों हो गए bonding, ये दोनों हो गए anti bonding. हमें करना क्या है? Half of bonding minus anti bonding electrons. So that turns out to be half of 4 minus 3. Again it turns out to be 0.5. So bond order is non-zero. That means the entities are not unstable. Both of them will exist. Both of them will exist. Both are unstable. So we cannot say that this is correct. This is stable. This is unstable. No. Li2 plus is more stable than Li2 minus. How can we verify this thing? Now it is important to know that ये एक बहुत ही empirical way है identify करने का कि what will be the bond order. Now whenever you see that two entities have the same bond order, then how would you identify the relative stability of these two species? Is that by comparing which one has more electrons in anti-bonding. हमेशा याद रखो, anti-bonding reduces stability, bonding increases stability. जितने electrons आप anti-bonding को देते हो, that means you're feeding your enemy. Whenever you are giving electrons to the bonding, that means you're doing a favor to your friend. So when you are doing a favor to a friend always returns the favor. आपने अगर enemy को ज़्यादा कुछ दे दिया तो आपका enemy आपको नुकसान कर देगा. So इलेक्ट्रॉन्स अगर आपने बॉन्डिंग मॉलिक्यूलर ऑर्बिटल में ऐड किया है तो स्टेबिलिटी इंक्रीज करेगी, अगर आपने एंटी बॉन्डिंग में ऐड किया है तो स्टेबिलिटी डिक्रीज करेगी. व्हेन बॉन्ड ऑर्डर इज इक्वल, द ओनली वे टू आइडेंटिफाई दैट इज बाय कंपेयरिंग in which case we have more electrons in anti-bonding molecular orbital. तो anti-bonding molecular orbital में यहाँ पे 2 इलेक्ट्रॉन है, anti-bonding molecular orbital में यहाँ पे 2 + 1 3 इलेक्ट्रॉन है, and since 3 इलेक्ट्रॉन है so हमारा Li2 minus unit will become less stable. So हमारा correct आंसर क्या होना चाहिए? Okay, so I hope you have understood this question. So let's move on to the next one. 2 pi and half sigma bond is present in. देखिए ये क्वेश्चन भी जेईई मेंस 2019 जनवरी 10th के एग्जाम में आया गया है, एंड दिस क्वेश्चन इज अगेन फ्रॉम मॉलिक्यूलर ऑर्बिटल थ्योरी. सो इट इज इंपेरेटिव टू नो दैट मॉलिक्यूलर ऑर्बिटल थ्योरी से ज्यादा क्वेश्चन आ रहे हैं यार. अगर आपने मॉलिक्यूलर ऑर्बिटल थ्योरी अच्छे से कर लिया तो एटलीस्ट जो भी मतलब केमिकल बॉन्डिंग से जो भी क्वेश्चन आएंगे एटलीस्ट कुछ तो आपने आइडिया मिल जाएगा. सो केमिकल बॉन्डिंग को अगर आपने अच्छे से करना है, आपको एक सेक्शन तो आपको पता है कि मॉलिक्यूलर ऑर्बिटल थ्योरी से आपको क्वेश्चंस आएंगे. सो प्लीज डू इट वेरी वेरी प्रॉपरली. इस क्वेश्चन को सॉल्व करने के लिए आपको एक सिंपल चीज याद रखनी है कि until 10 हमारे पास इन सारे स्पीशीज में, देख लीजिए, इन ऑल दी स्पीशीज टोटल नंबर ऑफ इलेक्ट्रॉन्स इज मोर देन 10. ओके, टोटल नंबर ऑफ इलेक्ट्रॉन्स इज मोर देन n2 प्लस द नंबर ऑफ इलेक्ट्रॉन्स इज 13 इलेक्ट्रॉन्स, 14 इलेक्ट्रॉन्स. O2 plus total number of electrons is 15 electrons, O2 16 electrons. When the total number of electrons is more than 10, how do we identify what will be the arrangement of molecular orbitals? This is a very clear cut rule. The rule is that for 10 electron system, 12 electron system and 14 electron system, or anything between this, anything in this range, the molecular orbital representation or the arrangement of molecular orbitals will be like this. Sigma 1 is, sigma star 1 is, sigma 2 is, sigma star 2 is, pi 2py, pi 2pz, sigma 2px, pi star 2py, pi star 2pz and sigma star 2px. This comes due to sp mixing. इसको याद रखिए, बस इसको टर्म याद रख लीजिए कि it happens due to sp mixing. In each of these molecular orbitals you can accommodate 2 electrons. Molecules which have number of electrons more than this, then वहां पे क्या होगा? Sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. The difference lies only over here. Sigma 2px, pi 2py, pi 2pz, pi star 2py, pi star 2pz and sigma star 2px. The only difference is in this part. बस इस पार्ट में डिफरेंस है. Okay, so if it is being said that 2 pi bonds and 1 half sigma, that means pi orbitals are completely filled. 2 pi bonds means pi orbitals are completely filled and 1 half sigma is formed. So half sigma मतलब कि sigma molecular orbital में only 1 electron is present. So 2 pi means 2 pi orbitals are completely filled. तो pi molecular orbitals कहां आ रहे हैं? यहां पे. Okay, so pi molecular orbitals are completely filled but sigma is not completely filled. That means sigma से इलेक्ट्रॉन आपने रिमूव किया है. sigma से इलेक्ट्रॉन आपने you first filled pi and then you tried filling sigma and you maybe filled it completely and removed 1 electron or filled it incompletely. So if pi gets filled first, then obviously this is not the answer and this is not the answer, because this is written for electron count which is more than 14. Okay, so this is obviously not the answer, this is not the answer. We have to compare between A and B. In A and B both, pi orbitals will be filled first, but in B option, the sigma 2px will also get filled, because if you start placing 2 electrons in each of them, तो यहाँ पे 2 electron, 2 electron, 2 electron यहाँ पे आ जाएंगे. Then the total count becomes 14, but over here the count is 13, and 13 will be possible if you do not put 2 over here and rather put 1 over here. So that makes the sigma molecular orbital to have only 1 electron, and because of that it will be a half sigma bond. So half sigma का मतलब 1 electron in sigma molecular orbital, and 2 pi means each pi molecular orbital has 2 electrons, a total of 4 electrons. So the correct answer for this question will be A. Okay, it's a very easy question, slightly involving a bit of technicality, but this can be understood very easily. इसको फिर से आप solve करने की कोशिश कीजिएगा and it will be easier for you to understand. Okay, let's look at the next question. This question came on the January in the January 11th paper, and ये question बहुत ही easy है. Okay, इस question को solve करने के लिए आपको सिर्फ इसका structure बनाना है. Question है the type of hybridization and the number of lone pairs of electrons present in XeOF4. So xenon का oxyfluoride एक compound हमने ले लिया. इसमें आपको बताना है कि what is the hybridization and the number of lone pair present. So what we can do is we can just draw it very easily. Xenon, oxygen will form a double bond. You put 4 fluorine atoms. Okay. Now do count the number of electrons of xenon. Xenon has 8 electrons in the valence shell, and if you put 1, 2, 3, 4, 5, 6, that means you have a lone pair which will be present. Okay, so this is your lone pair. I'm drawing like this. This is your lone pair. Hybridization is equal to the number of sigma bonds plus lone pair. So number of sigma bonds is 1, 2, 3, 4, 5 plus 1 lone pair. So total count becomes 6. Hybridization becomes sp3d2, and the number of lone pairs is 1. So correct answer would be C. बहुत ही easy question है, इसमें बहुत लोगों को याद भी रहता है, but people who do not remember, you can solve it very easily. Okay. So of all papers which were conducted between 9th morning session until 12th afternoon session, that means a total of 8 papers which were conducted, we had a total of 4 questions in JEE mains from chemical bonding. So 4 questions आना बहुत ही बड़ी बात है. इसका मतलब ये है कि ऑन एवरेज आपके पास एक पेपर में हमेशा एक दिन तो एक क्वेश्चन आ ही रहा है. सो आउट ऑफ 30 एक क्वेश्चन तो आपको केमिकल बॉन्डिंग से बन रहा है. आप देख लिए कि बहुत ही ज़्यादा डिफिकल्ट क्वेश्चंस नहीं दिए जा रहे हैं. दे आर गिविंग क्वेश्चंस फ्रॉम मॉलिक्यूलर ऑर्बिटल थ्योरी एंड हाइब्रिडाइजेशन. सो इट इज़ इंपॉर्टेंट दैट यू मास्टर दीज 2 पार्ट्स, एंड दैट विल बी लाइक द बेस्ट थिंग टू डू if you are doing some last minute preparation. Now from here onwards we will take some excellent questions and we'll try to solve it with the best of our abilities. So देखते हैं first question क्या है. For an O2 molecule, how many electrons are present in the molecular orbital which looks like this? For an O2 molecule, how many electrons are present in the molecular orbital which looks like this? Now if people who are not able to see the molecular orbital very easily, I'll shade it a bit. So this part is shaded and this part is shaded. Okay, the molecular orbital looks like this. Now how do we identify the shape of molecular orbitals? इट इज़ वेरी वेरी ईजी अ थिंग टू डू. ये हमारा लीनियर कॉम्बिनेशन ऑफ एटॉमिक ऑर्बिटल से आता है. इसमें करना बहुत कुछ नहीं है, सिंपल कंसेप्ट है. अगर आपका ये दो s ऑर्बिटल्स हैं, if this is plus and this is plus, which means that this represents wave function. अगर दोनों प्लस हैं या फिर दोनों माइनस हैं, then what you will get is a molecular orbital which looks like this. Okay, if it is plus, if it is minus, it will look like this. Okay, so always remember, if two lobes are overlapping with opposite signs, then there will be a region of no electron density which will be known as node, which will be created between the two lobes. ठीक है, और वो lobes एक दूसरे से away जाते हुए दिखाई देंगे. They look as if they are going away from each other. So this will be known as sigma. This will be known as sigma star. How do we label this as sigma or sigma star? Because s and s orbital head on ही overlap करेंगे. Invariably head on overlap करने के कारण they will always form sigma bonds. So if I take p orbital, and if they two overlap, remember, this plus and minus do not represent charges, they represent wave functions. Just have to remember that plus and minus represent symmetry. Same symmetry overlaps, constructive interference, opposite symmetry overlaps, destructive interference. Cancel out हो जाएगा. So you can see overlap is taking place. This will be known as sigma. But p orbitals can also overlap in a different manner. P orbitals can overlap laterally. If they overlap laterally, they will form a pi bond. Okay. So it will look something like this. If they overlap, they'll form plus plus minus minus. This represents pi molecular orbital. But this is where the answer to this question comes. This is the shaded part, this is the shaded part. Different shades means opposite wave functions. So ये shade और ये shade अगर एक जैसे नहीं है, then the lobes which are facing each other are not shaded in the same manner. That means destructive interference हो रहा है. Okay. Now, plus minus minus plus, they would not want to overlap with each other, and because of that they will try to move away. And if they try to move away, plus minus minus plus, ये plus को आप ऐसे भी दिखा सकते हो, इस तरह से भी शेड कर दिया आपने. So this represents a pi star molecular orbital. So this is a pi star molecular orbital. This one. We have to identify how many electrons are present in the pi star molecular orbital. Now, if we take the baseline idea which we had learnt earlier, that nitrogen has 14 electrons, तो 14 electrons molecular bonding molecular orbitals तो आपको completely fill कर देते हैं. But when we have O2, then two new electrons come. These two new electrons will go in the higher region, that means the anti-bonding region. एंड एंटी बॉन्डिंग में सबसे पहले ये पाई एंटी बॉन्डिंग को फिल करेंगे एंड उसके बाद सिग्मा एंटी बॉन्डिंग को फिल करेंगे. सो इफ दे फिल द पाई एंटी बॉन्डिंग फर्स्ट एंड देन द सिग्मा एंटी बॉन्डिंग, then the number of electrons which will be present in the pi anti-bonding will be equal to 2. आंसर 2 होगा. इसको हम और एक तरीके से प्रूव कर सकते हैं. अगर आपको मॉलिक्यूलर ऑर्बिटल कॉन्फ़िगरेशन लिखना आ गया, then it's very easy. ये आपने आइडेंटिफाई कर लिया कि पाई स्टार मॉलिक्यूलर ऑर्बिटल है, then you can write the molecular orbital configuration sigma 1 is 2, sigma star 1 is 2, sigma 2s2, sigma star 2s2, sigma 2px2, pi 2py2, pi 2pz2, and next pi star 2py1, pi star 2pz1, sigma star 2px0. कितने इलेक्ट्रॉन्स हैं आपके पास? 2 electrons. Answer should be B. Okay, so the answer for this question will be B. I've done a little elaboration of this concept because molecular orbital theory से questions आ रहे हैं regularly. It is a part of molecular orbital theory, so a lot of people find it difficult. इसको फिर से एक बार revision कर लीजिए, इसको फिर से एक बार देख लीजिए. It's an easy thing. Okay, let's move ahead. In SNF3, molecular orbital theory और hybridization से ही ज़्यादा questions आ रहे हैं, so we have taken most of the questions from these two parts. In SNF3, the FSF angle should be, so how can we draw this molecule? So S N F F F, ठीक है? Now हमें बताना है इसका hybridization क्या है. What is hybridization? How many sigma bonds are there? 1. How many? 1 sigma in this region, and there are 3 sigma in this region. So a total of 4 sigma bonds. That makes the hybridization sp3. So ideally the angle should have been 109 degree 28 minutes. But will the angle be 109 degree 28 minutes? No, because if all bonds are sigma bonds, then only it will turn out to have a hybridization of sp3 with an angle of 109 degree 28 minutes. But what we can see over here is a pi bond. A pi bond will repel this. Why would there be more repulsion? Because pi bond or this triple bond will have about 6 electrons. Triple bond will have 6 electrons. 6 electrons will repel 2 electrons to a greater extent as compared to 2 electrons repelling each other. Each bond will have 2 electrons. So 6 electrons repelling 2 electrons, this repulsion will be more. So nitrogen is repelling the sulfur fluorine bond, and so the bond will come closer, and because of that FSF angle should be less than 120, more than less than 109 degree 28 minutes. This is the right answer. Okay, this is absolutely the right answer. Okay, let's move ahead to the next question. Next question is again very interesting, a little challenging as well. इसके ऊपर एक क्वेश्चन, इस तरह का एक क्वेश्चन जेईई एडवांस्ड में भी आ चुका है, सो इट इज इंपॉर्टेंट कि आप इसको समझ लीजिए अच्छे से. Which of the following molecule the nodal plane of all the pi bonds is in the same plane? Nodal plane is that plane which does not contain any electron density. Generally it is present at the intersection of the two lobes. Okay, nodal plane is the plane which does not contain any electron density, generally present at the intersection of the two lobes. So हम इसको कैसे आइडेंटिफाई करते हैं? C6H6 को हम पहले बनाएंगे. How does it C6H6 is benzene, तो इसके pi bonds दिखते कैसे हैं? So I'll draw it like this. These are the p orbitals which will overlap laterally to form pi bonds. Now what you can see at the intersection of these lobes is a nodal plane. This plane will become the nodal plane, the plane connecting all the nodes. So this is known as a node, and the nodal plane will be perpendicular with respect to a pi bond which is formed. So this is carbon, this is sigma bond with oxygen, this is sigma bond with another oxygen. I'm drawing it a little elaborately. This will result in the formation of अ पाई बॉन्ड, ओके, ये लैटरल ओवरलैप से एक पाई बॉन्ड बनेगा। लेकिन CO2 मॉलिक्यूल इस तरह का दिखता है, C डबल बॉन्ड O, तो ये पाई बॉन्ड हमने बना दिया। आई हैव टू ड्रॉ वन अनदर पाई बॉन्ड, दैट अनदर पाई बॉन्ड विल बी ड्रॉन लाइक दिस। Okay, now the nodal plane for this is horizontal. It will be like this. इस वाले ब्लैक वाले के लिए, ये ब्लैक से जो हमने दिखाया है, इसके लिए जो नोडल प्लेन रहेगा उसके परपेंडिकुलर रहेगा, ऑर्थोगोनल रहता है। एंड इसके लिए जो नोडल प्लेन रहेगा दैट विल बी वर्टिकल, because this pi bond is horizontal, so nodal plane will be vertical. Nodal plane will always be vertical with respect, orthogonal with respect to the pi bond. Okay, so ये दोनों orthogonal with respect to each other रहेंगे। दो nodal plane है but they are not in the same plane. Two nodal planes but they are not in the same plane. Let's look at the next one. This is a similar representation as CO2 except for the fact कि इस ऑक्सीजन की जगह कार्बन कर दिया, the molecule still has the same representation of the central atom. So the two pi bonds will still be orthogonal with respect to each other, and so would their nodal planes be. So nodal planes are in different planes. So this is not an answer, this is not an answer. Let's look at N2. So in N2, N, okay, this is how we would draw the pi bonds. Okay, so now we have to identify what is the nodal plane for the red colored pi bond which is drawn. Okay, so nodal plane will be perpendicular to it. For this, the nodal plane will be perpendicular to it. Like for black one, the nodal plane, so these two nodal planes will look something like this. ऐसे दिखने चाहिए. So nodal planes will be perpendicular with respect to each other because the pi bonds are present in two different planes. But only in this case, there is one nodal plane, and for every pi bond, like let's say for this pi bond, the nodal plane is this. For this pi bond, the nodal plane is this. For this pi bond, the nodal plane is this. We have, for every pi bond, the nodal plane is present in the same plane. So the correct answer should be A. The correct answer is A. Okay, it's a very fun to concept. Please do remember that a nodal plane will always be present perpendicular with the with respect to the p orbital. Let's look at the next question. ये question बहुत बार पूछा गया. It's a very common question. It's given in NCERT and a lot of people choose to ignore it, but please don't do that. It's a very simple question, very interesting one as well. You have been asked that in copper sulfate 5H2O, how many H2O molecules form coordinate bond with the metal ion? This question can be asked in the topic of coordination compounds as well. This question has been asked in covalent bonding. So, कैसे solve करना है इसको? CuSO4.5H2O is drawn something like this. Cu So please do remember that this is the right structure of CuSO4.5H2O. In a CuSO4 5H2O molecule, there are 4 H2O which form coordinate bond with the copper Cu2 plus ion. One H2O molecule forms hydrogen bond. Okay, one H2O molecule, this one H2O molecule forms hydrogen bond with 2 sulfate units. Okay, so it is very, very important to remember that, like, let's say I have drawn a crystalline structure, like इस तरह का arrangement repeat होता रहेगा. So water molecules, 4 water molecules will form coordinate, 1 will form hydrogen bond. So correct answer for this will be B. This is given in NCERT, please do read it. I think it is given in the topic of hydrogen. So इसको पढ़ने की कोशिश कीजिए, इसको आइडेंटिफाई करने की कोशिश कीजिए, इसको याद रख लो. Copper sulfate 5H2O में 4 molecules H2O के, they will be present in the form of, or they'll form coordinate bond, 1 will form hydrogen bond. इसको याद रख लो, ठीक है? Suppose somebody doesn't know how to draw the structure of PSCl3, they should not worry about that, because the question is not actually about that fact. Okay, a few important pointers are there, that if chlorine is present, chlorine will be present as a peripheral atom. So peripheral का मतलब होता है कि साइड में आपका क्लोरीन प्रेजेंट रहेगा. ओके, सो क्लोरीन को आपने 3 बॉन्ड बना दिया क्लोरीन के साथ. लेट्स से आपने बीच में फास्फोरस को रख दिया, एंड फास्फोरस को बीच में रखोगे तो यू विल हैव टू फॉर्म 5 बॉन्ड्स. सो आपने सल्फर को यहाँ पे रख के 5 बॉन्ड्स बना दिए, ठीक है. लेट्स से किसी और ने क्या किया कि सल्फर को यहां रखा बीच में, एंड उन्होंने 3 बॉन्ड क्लोरीन के साथ सल्फर की बना दी, एंड फास्फोरस से ट्रिपल बॉन्ड बना दिया. सल्फर फ्रॉम 6 बॉन्ड्स, फास्फोरस फ्रॉम 5 बॉन्ड्स. दोनों स्ट्रक्चर देखने से तो लग रहा है कि हाँ नॉर्मली सही होने चाहिए. लेट्स से वी डू नॉट नो व्हाट इज द राइट स्ट्रक्चर. डज दैट अफेक्ट द आउटकम ऑफ द क्वेश्चन, आउटकम in this question? Let's see. Question is what type of pi bond is present in PSCl3? तो pi bond तो यहाँ पे present है. Now pi bond, whether there are 2 pi bonds which are formed or only 1 pi bond which is formed, the nature of orbitals which are overlapping will not change, because phosphorus and sulfur both are present in the third period. If they are present in the third period after utilization of all the p orbitals for hybridization. So what is the hybridization of phosphorus over here? The phosphorus's hybridization will be sp3. All p orbitals are involved, but so if all p orbitals are involved, the pi bond will be formed using d orbitals. अगर p orbital पूरे यूज हो गए तो pi bond बनेगा d orbital को यूज करके. So if d orbital of p is used, then it will be a 3d pi overlapping with sulfur. Hybridization of sulfur will be sp2, so its 1 p orbital is still left unhybridized, so it will be 3p pi 3d pi. हम इसमें देख लेते हैं. sulfur 1 2 3 4 sp3 hybridization, so it will involve 3d pi. phosphorus hybridization is, let's say sp हम ले लेते हैं, because 1 2 3 4 5 electrons in the valence shell, 1 sigma 1 lone pair if is taken, then sp hybridization, so p orbital is left for forming pi bond. I'll still get 3p pi, so 3p pi 3d pi should be our right answer. So it does not affect the outcome of the question. However, the question might seem like a difficult one क्योंकि आपको इसका structure नहीं मालूम है, but few ground rules होते हैं, उसको follow कीजिए. It will be easier for you to answer questions like these. Let's take the next question. As per the valence bond theory, which of the following overlapping is not possible? Now वैलेंस बॉन्ड थ्योरी का ये कहना है कि ओवरलैप्स बिटवीन एटॉमिक ऑर्बिटल्स विल टेक प्लेस टू फॉर्म मॉलिक्यूलर ऑर्बिटल्स, और these overlaps result in the formation of hybrid orbitals. तो ये हाइब्रिड ऑर्बिटल्स जो बनाते हैं हम, इसमें ऑर्बिटल्स को इस तरह से ओवरलैप कराना होता है दैट वी शुड नॉट ऑब्टेन नॉन बॉन्डिंग मॉलिक्यूलर ऑर्बिटल्स. नॉन बॉन्डिंग मॉलिक्यूलर ऑर्बिटल्स मीन दैट if somebody is having difficulty in seeing this, so this is a py orbital. Let me draw this. This is plus, this is minus. If a overlap takes place in such a manner, so you can see that there is a small region of overlap of plus and plus, small region of overlap of minus and minus. So this overlap is not allowed because this is results in non-bonding. So what we have to look for is if simultaneous plus plus and plus minus overlap is occurring with the same lobe, like two lobes are overlapping simultaneously, plus plus and plus minus are overlapping, so in that scenario we would not be ever having a bond which will exist. So dxy on x axis, which is the common axis, dxy, the first one is dxy plus dxy along the common axis, which is x axis. This is plus something like this. Okay, so this is a dxy यहाँ पे दिया हुआ है. Two opposite lobes will be having plus and plus. इसको plus और इसको plus नहीं कीजिएगा. So this is dxy overlapping. So plus and plus overlaps, minus and minus overlaps. It will result in the formation of a pi bond. When would we say that a non-bonding is formed? When a single lobe overlaps simultaneously with two. When a single lobe overlaps simultaneously with two. So this is allowed. This is allowed. So this is not an answer to the question. हमें बताना है कि not possible. So single lobes overlap simultaneously with two. तो आप देख रहे हो, single overlaps simultaneously with two. So B is not possible. Let's see if anything else is not possible. This is possible. sp2 along axis, they will, if they overlap along each other, they will overlap with each other because plus and plus एक lobe overlap कर रहे हैं and both of them have the same sign. Plus plus will overlap, minus minus will overlap, and this will result in the formation of a pi bond because at a given point of time 4 lobes are overlapping, and that this overlap will take place, this overlap will take place, this overlap will not take place. So this will be the answer to the question. So correct answer is the correct answer is B. Okay, the correct answer is B. So with this we conclude today's session, and I hope you had found it extremely helpful in understanding the concept of molecular orbital theory and a few basic parts of hybridization and overlap of orbitals. The important focus areas in chemical bonding are the VSEPR theory, the hybridization, the back bonding. Back bonding को बोलते हैं, resonance भी बोल देते हैं. Okay, so back bonding और resonance में फर्क कोई नहीं है. Molecular orbital theory is very very important. Weak intermolecular forces भी आप पढ़ने की कोशिश कीजिएगा, जैसे हाइड्रोजन बॉन्डिंग, लंडन डिस्पर्शन फोर्सेस. इसके ऊपर कभी कभार क्वेश्चन आता है, बट इतनी रेगुलरिटी में नहीं. बट you should always expect that one question definitely will be from chemical bonding. 1 or 2 question definitely chemical bonding से रहेंगे. Now there's a very very beautiful message for you guys who are preparing for or the April examination. So remember guys that if you want something that you have never had, you must be willing to do something that you have never done. It is like, let's say somebody wasn't very fortunate enough to do really good in the January examination, so that should not dishearten you. It opens you a new door to explore to what extent you can push yourself. So it is very, very vital that you realize this fact that you have a dying need of acing the examination that is in front of you, and इसको ace करना अगर आपकी एक dream है, if that is what you want to do, if you want to get into an IIT or into an NIT of repute and into a tier 1 college, that is what your dream is, to live there, to enjoy that life, to enjoy that vibrance of the college, then you must be willing to do what it takes, and something that you have never done. Like it's not like a 10th board examination या फिर 11th standard का स्कूल एग्जामिनेशन नहीं है, तो इसके लिए आपको उतनी ही मेहनत करनी होगी जितनी की आपने कभी नहीं की है. सो लग जाइए, हम भी आपके साथ हैं. डोंट वरी, post your doubts as much as possible. We'll try to get them resolved, and please follow us throughout this session for an awesome journey towards your JEE Mains 2019, which is going to be held in the month of April. So if you have liked this video, please do subscribe, like, and do hit the bell icon so that you are up to date with all the awesome content that comes from Vedantu. And with this, I take leave. The next session would be on coordination compounds, in which we would be discussing some very critical concepts of coordination compound, not going beyond the JEE Mains level. हम लोग JEE Mains तक ही अपने आप को सीमित करके रखेंगे, and that is what our objective should be. Our objective should be to get that 250 sweet spot, 250 plus sweet spot या 200 plus का sweet spot हमें चाहिए, and for that we do not have to do a lot of stuff. हमें कुछ एक चीज़ों को बहुत अच्छे से करना है. Okay, so with this, I Saurav Goswami take leave, and I hope you join us for the next session and be prepared for the next session as well. Thank you guys, and I hope you have a lovely day here.